Hello everyone, this is Reza and today we are going to be looking at a very interesting and beautiful problem, math problem to solve, which was basically asked in the admission test of Bangladesh University of Engineering and Technology, also known as Buet. So let's jump into the question, break it down step by step and make it easier to understand. Let's get started. So basically, this is the question where we are asked to find the value of an expression if a certain exponential value satisfied the given equation. You see this exponential term satisfy this quadratic equation here. Or in other words, the exponential term is a solution to this quadratic equation. And we need to find out the value of this expression where x lies between 0 and pi by 2. First, we see the expression we are given looks like this. That's a bit complex, but don't worry, we'll break it down step by step. You see, this sine series inside the exponential function can be rewritten as an infinite geometric series. If you're not familiar with this, a geometric series has a first term a and a common ratio r and goes on forever. In this case, both a and r are sine squared x. So we know the formula for the sum of an infinite geometric series, which is summation is equal to a over 1 minus r, where a is the first term and r is the common ratio, as I said before. So plugging in that sine squared x for both a and r, the sum of the series becomes tan squared x. So that's the value of our infinite series. Now, if we look at this exponential term, it is written as something like this: e to the power, the series into ln 2, which can be transformed into, as we have found out, e to the power tan squared x into ln 2, which can be rewritten as, you see, e to the power ln 2 to the power tan squared x, which eventually becomes 2 to the power tan squared x. It's the basic rule of logarithm. As the base of the logarithm is e, we can write it like this: 2 to the power tan squared x. Now let's turn our attention to the quadratic equation we were given, which is x squared minus 9x plus 8 equals to 0. We'll solve the quadratic equation by factoring it. Factoring gives us x minus 1 into x minus 8 equals to 0. This means x could either be 1 or 8. So now that you know that this equation have these two values as its root, so this means that 2 to the power tan squared x is either equals to 1 or equals to 8. Which means that tan squared x is either 0 or 3. And then taking the square root of both sides, we find that tan x is equal to 0 or plus minus square root of 3. Which leads us to x equals to either 0 or plus minus pi by 3. Now, considering the range of x, where x is greater than 0 and less than pi by 2, the only valid solution is x equals to pi by 3. Great! We now know the value of x, but we are not done yet. We need to find the value of this expression. Let's substitute x equals to pi by 3 into this expression. We know that cos pi by 3 is equal to half and sin pi by 3 equals to square root of 3 by 2. So substituting these values, the expression becomes something like this. Simplifying this, we get the final result, which is 1 divided by 1 plus square root of 3. And there you have it, the final answer. Thanks for following along. I hope this breakdown helped to make the problem easier to understand. So our problem was basically, it involves a mix of exponential function, trigonometric series, and solving a quadratic equation. But altogether, it turns out to be a very interesting and beautiful problem to solve, and we have done it. And thanks for following. If you like this video, please hit the like button and please subscribe my channel. This is Ali Reza signing out today. Goodbye.